Hey guys, this is the Chapter A Section 2 Part 2 video. So if you didn't check out Part 1, check it out. But we do have some tougher problems here in Part 2. So just like equation solving, and we did one like this in the chapter or the Section 1 notes. So anything in front of a set of parentheses needs distributed. Now the 6 isn't attached, right? But there is a negative sign there, and it's understood to be a 1 there. So if I were to distribute -1 times the 2, which most people don't miss. Now here's the tricky part. So if I do -1 times that 7, that sign's going to switch. Greater than or equal to 9. So the first step for solving equations or inequalities was to simplify, and distributive property is part of the simplifying process. But also, anything that's on one side we want to put together. So 6 minus 7, I'm going to go ahead and do it. Now I'm going to start moving stuff. Now I'm going to quit doing the little plus ones on underneath. I'm not suggesting that you should do this. I'm just a little low on room here. Okay, we all know that that -1 is going to get moved by adding 1. So I didn't show the work, but again, you're welcome to show the work. Don't think that you have to skip that. So how do we get rid of this -2? We divide. If you watched the last video, you would know if you divide by negative, you got to flip the inequality around. So x is less than or equal to -5 for my answer. The number line graph part, really easy. -5, more numbers to the right, more numbers to the left. I'm not going to bother putting more grid marks. Closed in circle because it's got the equal sign, the less than or equal to, and less than means shade to the left, or numbers smaller than -5. So that's called inequality notation right here, which is acceptable for an answer. But if you watch part 1 video, we want to try to rate these in what's called interval notation as well. And interval notation is just to say, where's my shade on the left? Goes forever. Where's my shade end on the right? It ends at -5. Brackets for closed-in circles. Parentheses when we're not including it. You can't include infinity because it goes on forever. All right, number 8. Again, fraction problems. Don't be scared of them. If you can do common denominators, which I believe most of you can, it actually becomes pretty darn easy. So can I turn that first one into something over 10? Yeah. The second one is already something over 10. And I can do the same thing to the third one and change it to something over 10. Well, how do I change it into a something over 10? I got to multiply by 2. This one I didn't have to mess with in the middle. And to change that last fraction to something over 10, I also multiply it by 2. So if you recall from the previous section, this is really good news because we get to do that. So no more common denominators, don't even have to concern myself. So what's left? 4 plus x, less than 12. And pretty easy to solve from here. I'm just going to subtract 4. X is less than 8. Open circle. I have no idea why all my answers end up being less thans. Coincidence. And interval notation is going to look pretty much like that last one. So what's going on the left side goes forever to the left. What's going on the right side, it ends at 8. So the difference would be I use a parenthesis for an open circle. I use a bracket for a closed circle. All righty, number 9. So check out some distributive property there. That's pretty much automatic every time. Times it by 4. Times it by 4. And then combine. Okay, so let's see. I got a 3a over here. I can do 4a minus 1a. That's 3a. And minus 8. So you're probably noticing something weird's going to happen here. But hey, let's just keep following the system, right? The system is to go ahead and get the a's on one side. So if I subtract 3a from both sides. Now I end up with 0. I can't not write something there, right? I mean, if you got an equal sign, you write something on both sides of the equal sign. You got a greater than, less than sign, you write something on both sides. So if you watch the section 1 video, you probably have an idea what goes on here. So the question is, if the variable goes away, are you left with a true or false statement? So 0 is greater than -8. And that means the answer is all real numbers. And technically, if you wanted to shade in the number line, that means it would be everything. right? Because it's all the numbers would work for that. So anything you plugged in for that problem would work. So, and interval notation would go like this. Forever to the left, forever to the right. And that's it. All right, see if I can squeeze in the word problem. Jim is selling advertising space in Math Unlimited magazine to local businesses. Jim earns 5%. So let's maybe highlight that guy. Well, if I can get this to work. All right, folks have no idea why this is not working. Well, I'll tell you what, guys. So we're going to go ahead and save the word problem for part 3. So I know that's going to break your heart. But if you want to see how this word problem's worked out, go ahead and check out part 3. In the meantime, I'll see if I can figure out what's wrong with my screencasting. Hey, thanks for watching.